ROM, read-only memory, beginner-level introduction. ROM, read-only memory, is a type of computer memory used to store permanent instructions that are essential for starting and operating a computer. Unlike RAM, ROM is non-volatile, which means data is not lost when power is turned off. ROM contains important programs such as boot instructions, BIOS firmware, system startup code, hardware initialization routines. Every time you turn on your computer, ROM plays a key role in starting the system. This topic helps beginners understand what ROM is, how it differs from RAM, why it is important, where it is used. What is ROM? ROM, read-only memory, is a type of memory that stores permanent data and instructions. In simple words, ROM equals memory that keeps important instructions even when the computer is off. A beginner view includes stores startup instructions, retains data permanently, cannot be easily modified, used during system boot. Why ROM is important. ROM is essential for system startup and stability. It helps in, say, booting the computer, initializing hardware, storing firmware, ensuring system reliability, running low-level instructions. Without ROM, computer cannot start, hardware cannot initialize, operating system cannot load. ROM overview, feature description, type, permanent memory, speed, slower than RAM, volatility, non-volatile, usage, boot and firmware storage. ROM structure. ROM is stored on chips attached to the motherboard. Characteristics. Stores fixed instructions, read-heavy operations, limited or controlled writing. Example of ROM representation. ROM equals firmware, BIOS, bootloader, startup instructions, permanent data, true. How ROM works. Step 1, power on. When the computer is turned on, power equals true. Step 2, ROM executes boot program. ROM starts executing stored instructions. If power, print, running boot instructions. Step 3, initialize hardware. ROM checks system components. Hardware OK equals true. Step 4, load operating system. ROM passes control to OS. If hardware OK, print, loading operating system. ROM versus RAM feature. ROM-RAM data, permanent, temporary. Volatility, non-volatile, volatile. Usage, boot instructions, running programs. Speed, slower, faster. Common types. 1. PROM, programmable ROM, written once. 2. EPROM, erasable PROM, can be erased using UV light. 3. EPROM, electrically erasable PROM, can be modified electrically. 4. Flash memory, modern and widely used in USB drives, SSDs. ROM in action, boot process example. Def boot system. Print, power on. Print, running BIOS from ROM. Print, checking hardware. Boot system, firmware concept. Firmware is software stored in ROM. Examples. BIOS in computers, firmware in routers, embedded system programs firmware. Device control instructions. ROM in embedded systems. ROM is widely used in microcontrollers, IoT devices, appliances. Example. Device equals type, washing machine, program stored in ROM. Full menu-based ROM simulation Python. Def power on. Print system power on. Def run ROM. Print executing ROM instructions. Def check hardware. Print hardware OK. Def load OS. Print operating system loaded. While true. Print N1 power on. Print 2 run ROM. Print 3 check hardware. Print 4 load OS. Print 5 exit. Choice equals input. Enter choice. If choice equals 1, power on. Elif choice equals 2, run ROM. Elif choice equals 3, check hardware. Elif choice equals 4, load OS. Elif choice equals 5, break. Else, print invalid choice. Comma. Permanent versus temporary memory. Boot process understanding. Firmware concept. ROM versus RAM differences. Embedded system usage. Real-life analogy. ROM is like a rulebook permanently printed in a machine. It tells the machine how to start. It cannot be easily changed. It is always available. Ways to improve ROM knowledge. Learn BIOS UEFI basics. Explore firmware updates. Study embedded systems. Learn microcontroller programming. Compare ROM types. Common mistakes beginners make. XX. Thinking ROM can be easily modified. X. Confusing ROM with storage. X. Ignoring firmware role. X. Assuming ROM is used for running apps. Where ROM is used. ROM is used in computers, BIOS UEFI, smartphones, embedded systems, IoT devices, consumer electronics, automotive systems. Simple definition. ROM. Read-only memory. A non-volatile memory that stores permanent instructions required for booting and operating a computer. Final summary. ROM is essential for starting and controlling a computer system. It enables system booting, hardware initialization, firmware storage, reliable operation. Understanding ROM helps you learn how computers start and operate at a low level.